This is 2,4-dinitrophenol and it has a lot of uses. But most notably, it has been used as one of the first weight loss drugs in the early 20th century. But because of its toxicity, it was banned in the 1930s, about which I will talk more about later. Before I begin, I must warn you, this compound is banned in many countries. It's toxic and explosive. This is in no way a tutorial, and you mustn't attempt to recreate this, not only because of the product's danger, but also because of the dangerous reactants. It's safe to say that this video is purely for educational purposes. Anyway, the synthesis I'm attempting is strikingly simple, and it has been done according to this paper from 2012. The starting materials are phenol concentrating nitric acid and 96% ethanol. To begin, in a beaker, around 100 ml of ethanol is poured, and to that, 25 milliliters of concentrated nitric acid is slowly added. After all of the acid is added, it's stirred a little bit and put aside. In an Erlenmeyer flask, I added 5 grams of phenol. Now you might notice that this phenol looks a bit purple, which isn't normal. Pure phenol is supposed to be white, but since this one is quite old, I think it was made in Yugoslavia, it absorbed some water and reacted with some oxygen, forming a little bit of compounds that give the phenol this color. But that doesn't really worry me because even though the color is quite strong, I don't think it's that dirty because a little bit of those compounds that are the oxidation products of phenol are needed to make such a strong color. Anyways, after the phenol was added, I poured the previously prepared ethanol nitric acid mixture and attached a reflux condenser to the flask. I turned on the pump for the water, turned on the heating, and let the mixture in the flask reflux for about 45 minutes after it starts boiling. The reaction that's happening here is just an electrophilic substitution where the hydrogen atoms are being replaced with nitro groups on the second and fourth carbon atoms. While this is refluxing, it gives me time to talk more about this compound. Now, if you're not interested in this, you can just skip to the timestamp on the screen, but if you are, stay here. Anyway, as I already said, the most notable previous usage of dinitrophenol was as a weight loss drug. It actually worked by causing mitochondrial uncoupling, which enabled the rapid expenditure of ATP, adenosine triphosphate, resulting in a much faster metabolic rate. This was actually noticed in people who were accidentally exposed to it, and they saw that they were losing quite a lot of weight, and that actually prompted researchers to see how DNP could be used to treat obesity. And it did actually well, but with many side effects. In fact, it was reported that under controlled conditions, people lost up to 0.9 kilograms per week. But when the dosage is not regulated, the effect can be vastly overwhelming, leading to extreme hyperthermia, which can and has already resulted in death. Besides that, it was also reported that DNP can cause various types of rash and cataracts, which can, of course, lead to vision loss. It caused damage to the immune system, cardiovascular system, and nervous system. And also in animal studies, it was found that it acted as a tetrogen, carcinogen, and a mutagen, which caused developmental and reproductive harms. So some animals became infertile, and the developing animals grew, well, in a wrong way. Since humans are also animals, technically speaking, I don't doubt that similar things would happen to us. But it wasn't used only for weight loss. Other uses include protection of metals from corrosion, as an antiseptic for the protection of wood, in the production of pesticides and herbicides, as well as in the production of explosive, because after all, it's a nitro compound, and nitro compounds are well known to be highly explosive. For instance, TNT, which stands for trinitrotoluene, is also a nitro compound, and it has only one nitro group more than DNP. Anyway, after the 45-minute mark, I removed the reflux condenser and added an adapter to the flask and also a Libby condenser so that I could get a distillation apparatus. While this is distilling, I just want to tell you that I have many interesting projects on the way, so if you like this one and would like to see the upcoming ones, consider subscribing. It would help a lot. Thank you. Anyway, the goal of this distillation is to remove as much ethanol, which should result in a much better crystallization of the product. Also, I must mention that the mixture doesn't have to be distilled, and it can just be heated to remove the ethanol. But since a lot of acetaldehyde formed as ethanol was oxidized by the nitric acid, just letting it evaporate would result in having a lot of acetaldehyde in the area, which to me doesn't smell great in higher amounts. The mixture was distilled until around 80 milliliters of distillate was collected. As the distillation was nearing its end, the product started crystallizing and it made the mixture boil violently, so I turned the heating off. After all of the ethanol and acetaldehyde mixture has distilled off, the residue in the Erlenmeyer flask was left to cool in the air, and as it did so, more and more yellow/orange crystals started forming. Those crystals were then filtered over vacuum and washed with ice cold water. The precipitate, those crystals, is basically our crude and relatively dirty dinitrophenol, which should be purified. To do that, the paper calls for a sodium hydroxide solution. It was prepared by mixing 8 grams of the hydroxide and dissolving it in about 200 milliliters of water, and that solution was then put on a hot plate to heat up. After all of the crystals were filtered off, they were put in a beaker and dissolved in a minimal amount of the hot hydroxide solution. Now, unfortunately, I don't have the video for this part because I forgot to press record, but believe me, nothing spectacular happened, and this is the result. To the hot mixture, 0.8 grams of active charcoal was added, and then it was left on a hot plate for 10 minutes with, of course, occasional stirring. The solution was yet again filtered, but since this time we don't want the precipitate, we want the filtrate, it was not done over vacuum, but rather via a gravity filtration. By adding sodium hydroxide to our crude dinitrophenol, we basically made a salt of sodium and dinitrophenol, which is way more soluble in water than the, let's say, free base dinitrophenol. But since we actually want the free base dinitrophenol, we must acidify the sodium salt solution. So to do that, concentrated hydrochloric acid was added with a dropper into the flask until the pH was around 2, which was then checked with a pH paper. And we can see as we add the acid that more and more of this dark yellow precipitate starts forming. And this should be our free base dinitrophenol. To separate it from the liquid, the whole mixture has to yet again be filtered, but this time, since we want the precipitate, it should be over vacuum. The dark yellow powder precipitate was collected and left to dry, yielding around 8.9 grams of the DNP. Now, I want to say that this looks a bit dirty, and I assume that's because of the active charcoal which passed through my filter paper, but I don't think that it's such a large amount since only a small amount is required to give a black hue to, well, basically anything. And this basically concludes this project. If you have any questions, feel free to leave them in the comments. I will gladly answer them. And that's all. Thanks for watching and have a great rest of your day.